had a daughter, she was all he'd talk about for months at a time. Just shut up. Sorry, I don't know what I'm saying. It's fine. Don't worry.
Good afternoon, everyone. Am I audible?
Good afternoon, sir.
Okay, just we start our session within 2 or 3 minutes because participants are joining. So just wait for other participants. So please wait for 2 minutes only. Then we start our session. Good afternoon, everyone, once again. Welcome to the last day of the course. Am I audible?
Yes, sir. Yes, sir.
Okay, perfect, perfect. So, in last session, we have discussed about the text to image model, that is the more about the LLM models, and then we have talked about the LangChain architecture of LangChain components, then vector database. We have just introduced the vector database, and then we have talked about the retrieval augmentation system, RAG. So basically, after that, we have demonstrated also how to we can integrate or implement text to image generation model, where we have discussed or demonstrated two models. So have you tried your own? Anybody has tried? Yes, please. Yes, anyone? Anyone has tried? No one? It was fine. Okay. Okay. So let me tell how many have we have basically demonstrated four models. 2 models for text to text generation, and 2 models for text to image generation. So how many have you tried your own? Because again I'm telling, if you do not try, you will not learn many things, basically defined in hidden forms, but when we try, then we can explore it. So I request to all of you, please try whatever we have discussed in the session and demonstrate it in the session. So now we begin our today's session. So I'm going to share the screen. Basically, today we talk about more about the fine tuning methods. What is the fine tuning methods, and what is the objective of fine tuning method? Then other models also we discuss. Like we have talked about in auto encoders, variational auto encoders, and many other models related to the generative AI or LLM. Okay, so I'm going to share the screen. Please reply me. Is it visible or not? One more thing, at the end of the session, that means today we basically uh, our conclude our course. So we will basically take a 20-minute quiz, MCQ, basically, it is a Google form based MCQ. So everyone you required to attempt this one. At in the end of the session, today's session, at the last 30 minutes, we will do this. Okay. So yes, is this screen is visible? Yes, please.
Yes, Yes, sir. sir.
Okay, okay. So now basically, so now today we are going to discuss about the fine tuning methods. What is a fine tuning? So if you remember, we have discussed different type of neural network categories, and one of them we have discussed about the self, basically you can say transfer learning. Transfer learning. So what is the basically transfer learning supervised method? It's a when we have one model, which is trained on some data, maybe data related to animals or any other. And suppose if we want to use this model, for our specific requirement or operation. So what we do, basically this data, suppose we consider this model is trained on the data of animals, like a data of a cat and dogs images, which is basically identified the image, or which is basically able to predict either this image is a cat or not, or dog or not. So this model basically trained on the numbers of dog and cat images. Now what we do, suppose we want to use this model for our prediction, and what we want, suppose we have a image of celebrity, and we need to be predict the particular image of which celebrity, either a particular name of the celebrity is there, it is a sport person, or actor, or maybe businessman, like this, or any uh, we can say leader, like. So basically what we do, we can say we can use this model, this which is already trained on this data, and after using this model, we can retrain or we can update this training with our own data. So that is called a transfer learning. That means whatever the model trained on the earlier data, we just need to be trained again or update the training of this model on the our own data, and then we can use this model for a particular uh, pr- function of particular problem. So this type of basically is called a transfer learning. And when we do this, it is called a fine tuning. Fine tuning method is what? That means we are to trying to train or learn existing trained model on our own specific requirement. That is called a fine tuning. Getting my point? On specific requirement. Yes, please. Is this clear? That is called a fine tuning. That means nothing. We have a one model which is already trained on particular data. And now what we do? We just try to train this model our own data. That is called a fine tuning. Or on data, or when it is used, so basically it is used for a particular company or organization try to solve particular type of problem or provide a particular type of a service to the customer, then we can use. Otherwise, to improve the accuracy of existing model also, suppose some existing model will not give the answer correctly, so we can also improve the accuracy of a model using the fine tuning model method. For example, in earlier example we have discussed one model that is now name is Google Flame T5 model, T5 large model. So what happened? This model basically give not a correct answer for a particular question, some question, correct response or answer on some question. So what we do? We can learn this basically model to give the correct answer. So we can increase the accuracy of existing model with the help of a fine tuning methods. So it is very important to improve the accuracy of model or to basically use the existing model for a specific task. Is it clear? Yes, please. Yes,
Yes, sir.
please. Everyone? Okay,
Yes, sir.
perfect. So basically, when we talk about fine tuning methods, how many types of fine tuning methods are there? So first category is considered as a full fine tuning. Full fine tuning, that means what? Suppose we have one model, and what we do, we try to update this model on the basically all data. So when we try to train the complete particular model on all the data and update to all the weight, then it is called a full fine tuning. That means in this particular case we need to be required the update all the weight information for a particular model, or we need to be perform the training on all the data, not a specific parameters. So that is called a full fine tuning. Now, which basically what is the limitation of this full fine tuning methods? It requires more GPU. GPU is what? Graphical processing unit, which is basically allowed processing a high computation processing. So graphical processing unit, GPUs, it require more GPUs, and it is very expensive, but obviously it give the effective answer, or it can basically give the efficient way. So it obviously this full fine tuning method is very effective, but the limitation is what? It require more GPUs and it is very expensive and time taking. Another method is called as a LoRa. That is a low rank adaptation. What we do, this method is also considered as an efficient method. Efficient, that means take a less time. They basically take a less time. How basically take a less time? Because it only try to change or fine tune the fewer parameters, not all the parameters. So when we try to change or try to train on a specific parameters or some sort of parameters, then we can say this is called a low rank adaptation, and it is very efficient. It takes less computational resources. Another basically we can consider as adapters. So what is about the adapters? So there are two types of adapters are available: QLA, ORA, and PFT. Both are the lightweight and memory efficient. What are this? We will discuss in next slide. And after that, the one more is a fine tuning method is instruction fine tuning. What is instruction fine tuning? That means we are to basically we try to we try to train a model on specific, on based of specific, on based of specific structure. So instruction based basically training also we can perform to do fine tune for particular LLM. So those are the basically we can consider the different methods for a fine tuning of a LLM. Now, see, as I told you, full fine tuning basically what to say. So full fine tuning refers the process of updating all parameters of a pre-trained models on a new data set. That means it basically updates the all parameters of a pre-trained model on new data set to improve its performance on a specific task. This differs from a technique like a feature extraction or partial fine-tuning, where only a subset of the model's layers are updated. Where in this particular case, feature extraction or partial fine-tuning methods, what happened? Only subset of a model parameters are updated. What is the advantage of full fine-tuning? Obviously, it achieves the higher accuracy on target task, more flexible than the feature extraction because it fully learn new patterns. It work well for domain adoption. If you new domains basically want to adopt, so it is basically that means you are changing the entire domain of the problem. So it is very effective where the target dataset is different from the original pre-trained. That means we can say a particular model is trained on the other type other domain of data, like we consider a image data of image data of a cat and dog. So this model, M1 model, is already trained on this image of a data set of a cat and dog. But when we try to use this existing model and train on the data of a, like a celebrity, as I told you, celebrity identification, name ID, then we need to update all the parameters. So in this particular, because now in this particular case, domain of a data set is entirely target domain data set of a domain of data set is entirely changed than earlier one. Okay, so in this particular case, if you want to change the or try to train the model on different data set, target data set, which is not a same as trend earlier trend on data set, so then we can use a full fine tuning methods. Okay, after this, second category is low rank adoption. Low rank adoption, as I told you, low rank adoption technique basically fine tune a pre-trained model on modifying a small number of parameters. So it basically selects some of or few parameters to train the model rather than entire model. It introduced low rank matrices into model weight, making fine tuning more and efficient memory friendly. So if you consider the example where it is used, so drastically reduce the trainable parameters, obviously. So from billion to million, means suppose if I have one model trained on all the parameters billion, so it can be considered into converted into million parameters. It consumes less GPU memory, feasible for consumer grade GPUs, prevent catastrophic forgetting by keeping the base model intact, easily switch between the tasks by swapping the different LoRa adapters. So those are the advantage we can consider for the LoRa fine tuning methods. Next one is adapters. So as I told you, basically the adapter considered two form, QLORA, QLORA and PFT. So when you talk about basically it is a lightweight trainable module that are inserted into pre-trained models for efficient fine tuning. Instead of modifying the entire model, adapter just only adjust only smart set of parameters, making fine tuning more efficient and faster. If you consider example, so first one is a QLORA, that is the quantized low rank adaptation, which basically improve the LoRa by applying the 4-bit quantization methods to the base model. So basically when we try to improve the LoRa performance, we can just apply this method and it is obviously take only it try to train the model or fine tune the model. So when we see, when we talk about the uh, training of a pre-trained model, when we talk about training of a pre-trained model, then it is called a fine tune. So when we say fine tune, that means we are try to train or learning the existing model which is already pre-trained on some specific data set. Clear? So this is the one category. Second one is what? That is the PFT. If we talk about a PFT is what? Parameterized efficient fine tuning method. So it's generally framework that include the multiple parameter efficient fine tuning technique like a LoRa adapters, prefixing tuning and prompt tuning. So those are the basically considered as a PFT version or variants. Next one is a instruction fine tuning. So basically what instruction fine tuning says, instruction fine tuning is a technique where a model is trained on a data set containing a task specific instructions and responses. This improve the model ability to follow the user instruction accurately. That means what we can understand here. That means instruction fine tuning method basically train the data set on a specific instruction based and responses. So it improve the model ability to follow user instruction perfectly and making it more useful for real world application. For example, instruction we try to give the instruction classify if the car needs service. So what is the input and response? If input consider mileage is 80,000 and engine light is on and tire wear is high. So we can say tire wear is a high, so we can say service is required. So this type of instruction we provide to the model on the basis of this one. Getting? And this also considered as an input prompt. So we can say basically instruction based fine tuning is basically based on the input prompt. What type of prompt we give? So input prompt, when we give the instruction based input prompt, then this type of fine tuning method is used. So when it is this method is used, when we try to improve the model accuracy on the basis of the ability on the basis of a user instruction or user command. Now those are the different methods which we have discussed in the basically regarding of fine tuning methods. Now we are taking the second, if you remember, when we talk about the generative AI models. So first model category we have discussed about the transformer. Yes or no? Transformer. And transformer, basically we have discussed different type of transformers also. Second category, basically we have discussed about the generative adversarial network. So what is basically generative adversarial network? That is called a JAN. So I told you real-time application. If you are explore some social media, like we consider example of Facebook, or we consider example Instagram or Snapchat. So if you see this reels or some images, so there are some images with some celebrity with a sport person. I think, have you seen this one? Celebrity with a specific uh, sport person, or some images of like some political leaders associated with the other one. So what are with this basically? And we also see some video also. So those images which we generally see on the different social media, actually those images are not a genuine image or not a real image, genuine image. Basically, those are the fake images which are generated by the generative adversarial network, and this particular domain is referred as a deep fake. So nowadays, basically deep fake is work. So every the image of the every person who is popular, either in case of celebrity or we can say sport person or political leaders. They are basically they try to create the images with some other persons and try to define a relationship between those. So basically those are the fake images are there. So if you want to create a fake images and try to detect the fake images, and it will also used for a image forgery, image detection, image forgery detection. That is the part of the security. So when you talk about image forgery detection, then this generative adversarial network is also used. So when we talk about a generative adversarial network, it is basically type of a neural network which is able to generate an image which is synthetic image. That means it is a fake image which is not actually exist in real world, but it look like a real. That is the concept of a generative adversarial network. Getting my point? Yes, please.
Yes, sir.
Yes, perfectly. Defect. Yes. Now suppose, as I told you, generative adversarial network basically used to generate. It is used to generate synthetic image. Synthetic, that means which is created by program. Synthetic image which is not exist in reality, but it's look like real image, real images. And also nowadays also video is also generated. If you see the image, if you have the very popular reels, if you have seen the reel of Prime Minister Narendra Modi and Home Minister Amit Shah together with one bike, and they are basically traveling. So this is basically the video is created. It is a fake video created by the generated or created by the particular type of model. This model. So nowadays basically everyone use this type of a network to generate a different type of content, either an image or audio or video like this. So when we talk about this one, it is able to generate or create a synthetic image which is not exist in reality, but it's look like real image. Now basically when you talk about this network, it has a two component. When you talk about a generative adversarial network, it has a two component. See, first component is basically generator, and second component basically is a discriminator. This is the discriminator. So what is the role of a generator? The role of generator, it generate synthetic image or fake image, fake image from the noisy data, from the noisy image of data, from noisy image data set. Okay. And when we talk about discriminator, so discriminator basically it try to detect or identify the image generated by the generator is real or not, by comparing with the original image or real image, original image. So basically, though both are the competitor, generator if you say generator is one component and discriminator is one component, so generator basically try to take some noisy data, image, lot of image noisy data, and generate one image. Generate one image. What discriminator say? Discriminator will say basically try to check this image and compare with there is one original image. Original image have with the discriminator and compare the both the image and say this image is a fake image or forgery image, and with the by the comparing this one. So what generator do? Generator again try to itself and try the best and again generate the image. So basically both are competitor to each other, or generator and discriminator both are compete to each other. Generator try to fail the discriminator and discriminator try to whatever the generated by the whatever generation happened by the generator, it is basically actual or fact. So this is the basically done. So in this case, in this particular competition, we can say the accuracy we will get very high, because generators always try to fail the discriminator and discriminator always try to fail the generator. So this competition basically give the more and more accuracy generated by accuracy of the fake image generation. So in this way basically generative adversarial network works. Now I'm going to show one demonstration to you how basically generative adversarial network can work, and basically it is a basically generate the image. Okay, so just see.
What is happening?
Hello everyone. Sorry for delay. Actually, slight electricity cut off there. Am I audible? Yes, please.
Yes, sir.
So basically, we are talking about the generative adversarial network, and I am going to demonstrate the how basically generative adversarial network works. So I'm going to share the screen. Please reply me, is it visible or not? Is this screen visible? Yes, please.
Yes, sir.
Yes,
Okay.
sir.
Yes. So you can see basically here I am going to share the one model that is a generative adversarial network model, and basically I have taken some data from the Kaggle. Are you comfortable with the Kaggle platform? Have you heard about the Kaggle? Kaggle is a data repository. If you see this one, so it is basically give the lot of data for different domains. So you can take it from the this Kaggle data repository, and you can directly access this Kaggle data repository to access particular data set in a Python Google Colab notebook. Why? Using this particular code. So here basically we try to all the Kaggle input. That means we are try to access the Kaggle repository and access this one. So before basically I go through this particular model, you can see basically how our gens work. So gen is generative adversarial network is work. Basically, first, as I told you, it has two component, generator and discriminator. So first component basically generate the things, and it use the supervised machine learning. Basic architecture, it use two neural network. Neural network is which one? First one is a generator, one neural network in the form of generator, and one neural network in form of a discriminator. And basically, it also use like this discriminator and generator both are considered as a neural network. So discriminator basically classify the given image is a real image. So if it is a real image, that is basically give the one value. It is a categorical data. And suppose a discriminator identify particular value as a fake image. Particular image is generated by the generator is a fake image. So it gives the zero fake image. Zero value for fake image. So zero value indicate the fake image and one indicate the real image. Generator is what? It gives the random noise and generate the some image for given input like this. So you can see this is the basically we have used the Keras dataset, and in Keras dataset we are accessing this CIFR 10. CIFR 10 basically it is a dataset which basically import the data, and you can see this is a dataset of different objects like vehicles, car. So it basically contain the object of a different image of different objects. So somehow some object like a car, truck or bus or some animals like horse or any other like this. So you can see this one. Okay. Now on the basis of this basically this data set given to the generator to generate some image about something, and this image is basically converted into 32 pixels. So we need to be how many here images are there? 50,000 images are basically considered as a train data set. Now try to implement this one. You can see all basically it is a form of a convolution neural network. So we need to just call the number of need to define the number of layers here, and after this this is a part of discriminator which is identified to particular given image is a fake image or real image. So this is the code for the discriminator. It defines the different layers. You can see this one. It basically generates the real samples. So whatever that basically try to generate the image of data, batch images of 64, and it basically used for the fake images data sample. There are two functions implemented. Now you can see basically we are try to generate the show the pixel values or basically a shape of the fake images that is in form of different numbers or values like this. Now we need to be train the discriminator on the selected genuine or real data set. We try to identify a given image is a see when the value 1 greater than or equal to 1 real 76.556, that is a 30%, 76% is real images and fake images basically 38%. So this is the basically give the uh, this is the training of the discriminator which identified the particular image is a fake image or real image. So how many images are real images and how many images are fake images. And basically we just use what is this number? This is number of epoch. Epoch that means iterations. And how many iterations basically we are try to identify. So in first iteration we give this one. Second iteration obviously it reduces the images and the accuracy. So basically the motive of the discriminator is to identify the given image is fake image or not. So if a discriminator give the percentage of a fake image is higher, that means it is more accurate. Okay. And then we come on to talk about the generator. Generator is what? Generator basically which help to generate the images, fake images on the basis of some noisy data. So you can see this. It is all about the convolution neural network. I also defined different layers and also try to generate a plot.png. So you can see this one. Now, now after the separate training of a generator and discriminator, we need to be just combine the both the concept here. So we can all generally combine the both the things here together. So here we are basically try to train the generator and discriminator simultaneously in this particular context. This is the entire training, and then now we come to the evaluating of the model. So this basically the basically when try to execute, so this already executed here, so I'm not going to execute this code entirely because it takes too much time, because it is basically work on the processing data image processing data, so it takes too much time. So you just I show the code. If you have enough time and have a good GPU or processing power, then you can execute this one. This code also I shared with you. You are try. Yes. So I also shared with this one. You can also download and you can try it. Okay. So please try it, because if I try to execute it, it take too much time. Like in last session, I am trying to implement one model which try to generate text to image generation. So similar kind, it will also take some time. Okay. Is this clear? Please, yes. Please, anybody in confusion? Okay. Now we come on our next concept. So after the generative adversarial network, we come on the next thing that is called an autoencoder. So now I'm going to discuss with the autoencoder. So when we talk about autoencoders, basically autoencoder is a type of a transformation. It is a type of transformers. Okay, so type of transformer, that means what? Obviously it used to generate something on the basis of some problem. So sometime it basically also used to the image reconstruction or uh, image size reduction or dimensionality reduction also. So basically it is also we can say directly it is also type of a neural network. Type of a neural network which can be applied with the image or any other type of data. Okay, so autoencoder have a different category. How many categories are of autoencoder? First, we consider if autoencoder, first type of autoencoder is what a stacked autoencoder. Stacked autoencoder. So when we talk about stacked autoencoder, basically this type of encoder used to reconstruct image reconstruction. This particular type of so stack autoencoder basically used in image reconstruction. That means what it does, when we have suppose given some image and image is destroyed or distorted image. So suppose we get some input image and image basically we consider this input image which is represented in form of a vector. Form of vector, that means what? Each image basically finally after the neural network fully connected layer we get in form of vector. So we consider one image like we consider the image of this like this image. So this is basically some points of pixels are destroyed here. So what we do, we just take this image vector and just give to the encoder. So encoder is what? Encoder is also one basically we can say it is a network which perform one operation that is called a G of phi, and then it is basically give to the one data set that is represented as basically as a Z. And what is Z? Basically it is represented as a n compressed low, it is a compressed low dimensional representation, dimensional representation of the input. So this is basically represented by the Z. So when we give the input image, vector form of input image to the encoder, and encoder performs some operations, and we will discuss what is the operation performed by this one. It will give the output as a Z. Z is what is the output of encoder? It gives the compressed low dimension representation of the input. And then this low compressed input dimensional representation given to the decoder. So basically decoder what does? It decode the given input or a compressed low dimension reduction of the input into the original one. So it performs the f of theta, function of theta. And then we get a output or reconstructed image that is referred as a x dash. So x dash is basically it is a reconstructed image. So suppose we have some input image and which is not very clear and very important. So then we can compute or we can reconstruct the input image into original one. So reconstruction image is basic concept. Now, when we are talking about this one, you can say it basically use one cost function. So like a g of 5 and f of theta, those are the cost function. How much the cost for the performing to this one. My voice is audible? Yes, please. Okay. So cost function basically how we can represent. So it basically represent a loss of theta comma phi. It is a mathematical representation, and how we can represent like this 1 by n, then summation of I equal to n, and we can write like this x of I is the variable. Okay, and when we perform this f of theta, f of g of phi of x of I, then secure this one. So this will basically define the loss function of the Gödel method, where theta basically define the weight, and phi define the basically biases. And this is the basically compute the loss of the or error of the this autoencoder function. Clear? So in general, we can say stack autoencoder is a type of autoencoder concept which is used to perform the image reconstruction operation. Suppose we get an input image which is distorted or some features has been lost, then we can reconstruct the lost feature or deleted feature of the image, original image. So this is the one way. Another one is a denoising autoencoder. If you talk about the second one is the second category of autoencoder is a denoising autoencoder. So when we talk about denoising autoencoder, what it does basically this use it also basically use the uh, to improve the quality of image which we have some noisy images are there, like some blur images. We will get some blur images, we need to be qualify, or somewhere you need to be clear the blur images, then we can use a denoising autoencoder. Suppose you are nowadays you are looking, there are a lot of tools, AI based tools are available, which basically if you give some blur image, and if you give some blur image as input, and you will get a perfect or accurate image of a same with that means we can use a lot of AI tools which basically uh, improve the quality of the images, input images. That means the blur images converted into perfect images. So how it is possible? It is only and only possible by the denoising autoencoder. So how it basically it work? See, what basically in this particular context denoising autoencoder does, it first take original image, that means original image input in a vector form. So you can define different feature like this, and this in this way. Okay, and we consider example of this is a 4-digit 4. Now what we do, basically partially input destroyed. Suppose this image data is destroyed, so some partially partially input is destroyed. So we can say consider some pairs like some features are destroyed here like this feature is destroyed, or we can say it is removed out. Similarly, another is also removed out like this. This one. So when we try to suppose we this feature are removed out from the input, if we want to reconstruct those feature of the image, then we can use a denoising autoencoder. So what it does, basically we give this input, so we consider as a input x as a image input of vector, and we consider those feature which are removed and which exist in the image data like this. And now suppose if we do this one, our some image we are removing some maybe our data maybe like some give some data like this type of images. So we have this images like this in this way. It is not a clear images. Okay. Voice is yes, please. Am I audible properly? Yes, please.
Yes, sir.
Okay, okay. Perfect, perfect. So now basically this input image is given to the encoder. So encoder basically what we are giving here we giving the denoising image with the distorted feature, and this is basically perform one operation function g of phi, and then it is converted into compressed dimensional reduction, and then this is basically given to the decoder. So why basically do we use this one? Because we have multiple images, large image data set, and we have each image is a high pixels. So we need to be processed for this. We need to be compute this one for decoder purpose. We need to be compute encoder basically perform the dimension reduction and reduce the size of the images, and then decoder take this one and again decode it. So it perform the function of phi. So not phi theta. It is a theta. Okay, and then it decode the real image with this, with the all features, or reconstruct the distorted feature of the images. So you will get a exact image like this one. Reconstructed input. Reconstructed input. So nowadays every in image processing tools basically, so you give the some blur images or some distorted images, so your image will be complete or your image will be clear. So all are happened about by this denoising autoencoders and strict autoencoders. Now after this we talk about the one more is a variational autoencoder. So variational autoencoder is much we can say effective than a denoising autoencoder. What it say? Will say basically it performs some more probabilistic based in operation in encoding part as well as some probabilistic part calculation and decoding part. Okay. Okay. So when you talk about a variational autoencoder, so variational autoencoder basically it is a kind of a autoencoder which allow to reconstruction of the image of a in case of a destroyed images or blur images. So basically the motive of this variational autoencoder same as like a stacked autoencoder and denoising, but the operation is different. So it takes some vector images of the particular input, and when we give this input image, input vector of image, input vector, so basically it parallelly perform two operation. First is perform the mean of the pixels or data, and then perform the standard deviation. So this is the different in a context of a variational encoders. So this compute the standard deviation, and when we by the combining the both of the output, it assign or give to the basically next, that is considered as a compressed dimension data, or those are sometimes referred as a simple latent vector. Simple latent vector. And when we give this particular compressed dimension to the decoder, so decoder basically form. So basically it perform the probabilistic decoder, and which is the probabilistic conditional probability. So it basically try to compute the what we can say function of theta with respect to x to z. This is the conditional base, and then try to give the reconstructed image or reconstructed output. So in this way, basically variation works. So it use some different law and probability also. So basically it is computer mathematics, but the motive is what uh, the same similar like devising encoder, but the more recursive and less computational resource. Okay. After this,
Sir,
yes,
सर आप प्रोबेबिलिस्टिक डिकोडर का फंक्शन एक बार और बता सकते हैं?
basically the conditional probability compute the computation perform, so which perform the conditional decode. That particular it will be used in image or not. So during the decoding of the image or reconstruction of the image, it performs the conditional probability, and it is use the entire concept of a probability, conditional probability concept. So we need to be move on the theoretical part. Am I audible? Yes, please.
Yes, sir.
Okay. So basically, decoder, what happened during the decoding of the image of the from the press input, it basically transforms the construction of the image conditional probability. So from the conditional different feature of the images, and then take a decision either particular part or feature may be. Sorry, actually, there's some network issues there. It repeatedly disconnected automatically. Okay, so again, share the screen. So basically, I'm telling about the sorry, variational autoencoder. And in variational autoencoder, basically during the decoding of the image, reconstruction of the image, basically conditional based probability methods implemented, which uh, uh, which provide or offer to take a decision of a reconstruction of image, which particular feature will be considered in the reconstruction, and on which particular feature based on the which particular phase. So some feature which will be taken to reconstruction of the image is based on some conditional based feature. So that is the part basically included in the conditional based probability. And there are a lot of entire mathematics conditional probabilities required to implement here. So we do not explore this one. We just know the how basically it works. Now we come on the next concept, that is a meta learning. So when we talk about a meta learning is basically what? It is a learning of LLM. So suppose we want to learn a LLM on the basis of some other feature. So we can use a meta learning. And it is also basically type of fine-tuning methods. So when we want to train or learn existing or pre-trained LLM, there to perform a specific task, then we can perform a meta learning. So meta learning is a type of fine-tuning method, and it is basically take it two steps. First one is a meta, and sometimes it is also referred as a learning of a learning, like a metadata. So what is a metadata? Metadata basically referred as a data about data. Data about data. That means a given data we have, what is the fact about the data? So data about data is what, suppose we have file, one text file or notepad file is there, and some content is written in this file. So actual those content written in this particular file is called data. And when we this content save in particular notepad file, like we can say hello dot text. So this file name, the extension, size, location where it is basically this file is saved, or we can say date of creation, date of modify, all are basically considered as a metadata. Data about data. So those are the basically considered. So file size, file type, file name, location, date of creation, all are considered as a metadata. So that is the data about data. Similarly, meta learning is what basically, but it say how to learn of a learning. That means the what particular type of LLM is learning, that's learned by the model. So meta learning basically perform in two way. First one is a meta training. Meta training, that means how to train the model. So basically the process or the steps basically to train the model is basically defined in the meta training. And then second one is the meta testing. So how we perform the testing? and what are the parameters you use during the performance testing, basically considered in the meta testing. So there are 2 steps for performing a meta learning, and there are different methods for a meta learning are there. What are the methods are meta learning? So some methods for meta learning are: first one we consider is a model based learning we can perform. Model based learning. Second one we can say metric based learning. And third one basically optimization based. So generally there are 3 methods basically used in the meta learning, and each one basically used in different context. So this is the some overview about the meta learning. After this we come on the next concept, that is called a graph neural network. So it is another term which is basically defined in the context of a LLM or generative AI model. So what is a graph neural network? So when you talk about a graph neural network, it is a special type of a neural network. It is also type of neural network that designed to work directly with the graph structure data. They're designed to work with directly with the graph structured data. That means what? Suppose in earlier we have discussed the convolution neural network. So in convolution neural network, that is what we are giving the input as an image. But at the place of image, when we try to give the input as a graph, which is some comprises of some vertices and edges, and then we need to process this graph and need to be perform some operation or need to be take some decision, then we can use a graph neural network. Okay, and basically where we use this one, so multiple applications are there where we can observe the application of this graph neural network, like a social network. So social network basically social network application like this Twitter, Instagram, Facebook, LinkedIn, where they nowadays basically are use the graph neural networks. Another one is a molecular or knowledge graph. Molecular the structure to understand the molecule, because moleculars basically for a particular medication define the structure graph structure way. So we can say molecular or knowledge graph. This is another application. Molecules or knowledge graph. So those are the area where we can see the implementation of a graph neural network. Clear? Now, when we come on, so you can see basically this. If you see this structure, you can see this one as an input image. We have given on a graph, and this graph is basically different hidden layers, maybe different parameters also. So it work on, and on the basis of take some reduce the non-linearity. So ReLU basically function used to the reduce the non-linearity. And then we give this one in a hidden layers value, and then we will get again perform the ReLU and we get an operation. So this is the basically way, or we can say architecture of a graph neural network. And I told you where we can see the application of this graph neural network. So when we have a graph data and we want to perform some prediction or some classification, then we can use this graph based neural network, and it is used in social networking and molecular analysis. Now we come on the type of a graph neural network. So when you talk about types of graph neural network. So first type, basically we can say it is a graph convolution neural, GCN. GCN. It is N. Graph convolution network. When we use this particular type of network, when we have a spectral graph convolution, when this particular graph convolution network is used, when we have spectral data, so spatial data, then we can apply this spectral graph convolution. Another category is, or another type is graph attention network, JET. Graph attention, yes, attention network. So you can say just like a JET, but it's a generative adversarial network, so it is referred as a confusion with the JET. So it is called a graph attention network. Graph attention network. And when you talk about a graph attention network, what it does? Basically, it performs the attention mechanism to weight neighbor's importance. So it finds the importance of a neighbor. It uses the attention mechanism. Attention mechanism. That's why it is called a graph attention network. Attention mechanism. And third category is basically considered as a graph isomorphic network. Third type is a graph isomorphic network. So this particular type, say, it is basically used to strong expressive power. Strong expressive power. Or because it is a similar to Whisper-Lemon test. Whisper-Lemon test. So those are the different type of graph neural network are there. Clear? And after this, you can see this one basically show the graph neural network architecture. So it basically some we can say medical molecular analysis. So it is basically represented the particular graph. So you are considered as an input tensor, and those are basically defined like multiple processing blocks. Then it performs the self attention pooling, attention GI, attention based GIN. So this is the basically a structure selection of a molecules. So in this particular, there it is a two component. The first one is considered as a local graph neural network, where it talk about the structure extension as a powerful structure extension of the particular node or graph, and then substructure selection. So first is defined as structure, and in this particular structure, substructure is this particular part. Selection is there, and then perform the interaction between the different structure part. So it basically give the combination of different to define this one. So it perform the interaction between different molecules graph and try to predict the some class level. So which particular type of molecular structure following which type of formula or medicines. After this, the next concept is become that is called a neural architecture search. So what happened in neural architecture search? Basically, we can say it is a technique which is used in automated machine learning. So we can say that means basically it allow us to select appropriate neural architecture for given problem or task. Given problem. That means manually we do not require to select a respective neural architecture. On the basis of a problem, this neural architecture search, basically the name is a neural architecture search. So it is basically comes under the category of automated machine learning. It is comes under the category of the automated machine learning. So in this particular say, it is able to select appropriate neural architecture for a given problem. So whatever you see, this is the architecture. Search space we have given. Now in the search space, the first one, you can say one-shot approach. So learning model architecture, parameter and weight together. So in this particular learning model, the architecture parameter and weight given both together. So first is you try to search strategy, which type of searching you need to apply, and after the search, use the search strategy is just try to search the appropriate architecture for given search space problem. So perform the after the architecture selected, it perform the estimation strategy. If it is okay, then performance the estimate of A. So it try to estimate the performance of A. So basically this is the neural architecture search. And what are the component of a neural architecture search? The first one is a search space. Second one is a search strategy. Search space where we need to be perform this particular model, and strategy which method or which technique we need to implement this one, and then we need to compute the performance or uh, evaluate the model performance. So that is called a performance estimation strategy. It defines the strategy to evaluate the selected neural architecture. Clear? So this is the basically considered as a neural architecture search. And after this, those are the component, as I told you, component of a NAS, that is a network architectural search, directed representation, graph representation search, cell block, meta architecture, optimization method. We can apply reinforcement learning or evaluationary search or gradient based optimization or bias, any one of them. Then evaluation method we can use perform as a full training or partial training or based shading network morphization. So you can see this is the neural style transfer. This particular it combined the basically next concept. We come to the next concept. It is a neural style transfer. So how we can see. Basically what it does, it basically take a future of two images. So what happened? I try to embed the future of one image into another image. So see this one. We can say it is also type of a network, neural network, or we can say it is also type of a deep learning type, which combine the content or feature of a one image into another image. Okay, and it created a new one image. So see, we consider this image input image, and we consider another image, and here we try to take this content or this design of this image into put into this image, and now we get this output image. So this is called as a neural style transfer. So this is the output, this is the input image, and those are source image which we need to be take or copy the content or uh, information to apply the input image, then we get output image. So nowadays what happened, this design or color all is basically applied on this in this given image. So you can see this one. So that is called a neural style transfer. Clear? Yes, please.
Yes, sir.
Okay. So this is the basically architecture you can see. So what this neural architecture, neural style transfer network does, it take a two image. First image is as a actual image or input image, and another is a another. So it basically both the image considered as an input image. In both input image, what one image where we need to be paste or copied the feature of another image. So we can say this is the basically target image, target input image, where we need to be copy the design or color or whatever the content of the another image into this image, and this is the source image. Source image source image is what? Source image is the type of image where we need to be copy the content of it and paste into a target image. So we take those two images, then we represent the content in a matrix form, and then perform the convolution operation, then max pooling, and the multiple operation are there. So all the operation, convolution, max pooling, straight, again convolution. So we can apply the sequence of a operation for the both the image. First one is a what? In source image, and another is a target image. So style reconstruction, we take this one from this image, basically try to reconstruct the from we can say this is the basically edges of this images reconstructed here, and then again filter this one, again then process there. So you will get this images here, and similarly this input is also applied on this first initially convolution operation. So try to deduct or identify the broad edges of these images, then minor images, and then more deeper, and go to this image. And after this, apply this particular content on this image, or copy this style of this image into this image, then we will get a target image. You can see this one. So we apply this one and you will get a target image. So this is the basically uh, we can say this is the talk about neural style transfer network. Clear?
Yes, sir.
Okay. Now we come on the next one is a self-supervised learning. So this is the self-supervised learning is a type of a machine learning, third category. And what we do basically in this, we have given different data set. So first is this is the data set of without any label. So data set of different images. And second one, we give some data set with some labels, like the image of this is a car, the image of this particular object type. And what we do, we give both the data set to the model, and it perform the pre-training model, and then give the target model. So this is the pre-text task, and this is target task. So it basically try to learn or train and give or predict the output on the basis of both the things, data without label and data with the label. So in this particular context, it perform the unsupervised learning, and in this particular context, it perform the supervised learning. Clear? So basically, this used to improve the performance of the machine learning by integrating the feature of a unsupervised and supervised machine learning. So that is the motive of the self-supervised learning. So you can see this one. We have some data, pre-trained data. So this is the image of us like a cat, parrot, and bicycle. So we given to these images perform the convolution operation, max pooling and other operation, then represent the pre-text data. So this is represented in some sort of text data. And what we do, we just try to this model or fine tune this model on the images of the dog. So what does, we just take it this one, try to learn, train on the only. So whatever the picture or input images, this model is already trained, we does not need to change, we just try to train on this given dataset, new dataset, and just perform the same training operation like earlier one, perform the convolution operation, max pooling operation, state operation and something, and then define the representation and classify. Then this model is able to answer up this image, either this image is a dog or not. So this is the basically self-supervised learning. So initially it basically try to train by the unlabeled data and then try to train on the labeled data. So this is the way of self-supervised learning. You can see this one also. This is the rotation of different images. Now after this, we basically talk about the next one concept is the neural ordinary differential equation network. So if we talk about this type of network, we can say it is a class of a deep learning models or neural network that blend ideas from differential equation with the neural network. That means it try to implement or integrate the concept of a differential equation with the neural network. And basically it is introduced in 2018 paper Neural Ordinary Differential Equation by Chen and the other co-authors. They offer continuous depth alternate to traditional deep neural network. That means we suppose try to this one, it perform like a you see. This is basically labeled with the 4SU and barcoding the SARNA. So this is the labeled accounts and this is the unlabeled counts, and we can give this a input layer to the neural ODE. So at the intermediate level, it basically neural ODE work. Okay, and then give the different concept of differential equation, and you can say initial cell state, train the RNA forecaster and prediction of the future cell states. So in this way, basically it is defined. So it basically implement the concept of a differential equation in neural network theory. Next one is a capsule network. It is very popular, capsule network. So when we talk about a capsule network, it is a type of a neural network architecture, and it is basically introduced by the Geoffrey. Geoffrey, one author is there, and the motive of this invention is basically define the hierarchical relationship between the task and perform the post variational in visual data. That means it used to post variational in visual data. Visual data means image data or video data. Okay, so basically it tried to preserve the spatial group of neurons, or we can spatial relation between the parts of the object. So it basically try to preserve the spatial relationship between parts of an object. So this is the basically considered as a capsule neural network. So you can see this one. It give the input images, define the different input set convolution plus ReLU operation is there, and then defining different further steps, convert into further steps, then define the multidimensional, or we can say basically find the relationship between the spatial relations between the objects, and then define the class capsules. After that, we come on the next topic, that is the federated learning in AI. What is a federated learning in AI? So when we talk about a federated learning in AI, it is basically is a type of machine learning approach that allow multiple decentralized devices or client to collaborate by train a shared model while keeping the data is localized. That means what happen? Suppose multiple in a cloud environment, multiple location, multiple team work on the to train the model. So if a model have a entire copy of this and try to train here locally, and this is also try to locally here. So earlier what happened? Basically, suppose uh, earlier was one model is centralized, and suppose at the different places person need to be use this or train this one. So what happened? They take a entire model copy to their own machine or their own local site, and then train this model on or their own specific requirement, and after the training it again need to be reintegrate the entire model. So this take too much time, and for uploading and for downloading take more computation. So what happened? Basically, the model is a placed on one central place, and individual user try to train the model on the centralized basically level. So it's center at the center one point. So what happens? You can see this particular, suppose this particular device or client want to train on this data set, and suppose from the entire model it just try to implement or update the W1. So it does not take an entire copy of the model. It's their local machine. It just try to take the fetch of a W1, work on the W1, wait and just update it. Similarly, this machine also work on W2. Similarly, this machine also take on a W3. So model placed at one place and different from the different location, different machine or clients are access this one, and they can update their own specific weight or own specific information. So it does not require to copy or upload the or entire model on their local machine, which take too much time, and again again recombine all the updation at different places or different locations at one place again. So this is the save the entire thing, that is called a federated learning in AI. Clear? And after that, we just next concept we come on the quantum machine learning. That is what is basically the idea of the quantum machine learning QML is that means when we are performing any type of machine learning, either supervised or unsupervised or semi-supervised or info, basically we need to be require some computation. So now we have a computation resources like a CPU, GPU, and TPU like this. Okay, but what about the more? So when the large data size or suppose a complex data like a DNA analysis, so we were perform work on DNA data, so we need to too much computation for do this to resolve this or limitation or to solve out this problem. Basically quantum computing is coming now. So when we have a quantum computing machine, and when we apply to some kind of a machine learning on quantum computing machines or resources, then this is considered as a quantum machine learning methods. So see, in a classical machine learning, what happen? We have a data classical in 0 and 1 bit. Yes or no? We have performed some mathematical algorithms, GPU, CPU, GPU processing. We just need to be select for the processing and just find out the pattern recognition. So, but what a quantum machine learning happen? Data is basically represented quantum data like a qubit, 1 and 0. Basically, it is represented the smallest unit of a data in a quantum computing qubit, and then we perform the some suppression of state, mathematical algorithm, quantum processing, and pattern recognition is there. So it takes too much time. You can see the time taken by this QML, that is a quantum machine learning, it is too short than the time taken by our traditional classical machine learning. So that is the concept of a quantum machine learning. And you can see n equal to 3, so 3 bits are there. CML, classical data is there. So it performs the CD data transform to QD data transform to this one and this one. So take a 3 qubits to the power n equal to n possible states quantum data is there. So that is the basically considered as a number of, we have a data increasing day by day, then we can do the machine learning algorithm with the help of quantum processing, which is considered as a quantum machine learning. Clear? Where we can see the application of this quantum machine learning. So in face recognition, entertainment services, self-driving automation, finance, recommendation system, and our genetics. In those different systems, we can use the quantum machine learning approach. Clear? Everyone? Yes, please. Next one is a AI explainability techniques. What is a AI explainability techniques there? So when we talk about AI explainability technique, it is also short form as XAI, that is explainable AI, which aim to make a decision of AI models understandable, transparent, and trustworthy to humans. This is crucial for high-stake application like a healthcare, finance, and law autonomous system. So what does basically does? It takes some set of input feature, perform trend or deep learning models like a convolution neural or any other model depending on the type of problem or input. Hidden layers and computational units are there, then resulted of classification, regression, clustering, any of the output prediction. So on the combining of this, it gives us some knowledge, and the knowledge matching with the, if you see this one, semantic technology knowledge graph plus ontology created here, and it perform the cross discriminative explanation and interactive explanation. So this basically they only take a decision to how basically AI model work and how basically they may be transparent for humans. That is called a AI explainability techniques. Now, next one is a synthetic data generation. What is a synthetic data generation? Synthetic data is what? A data is which is not actual available in reality. That means a fake data, like a fake image, fake data, or we can say a data which is not exist in reality. So on the basis of some ground or some basis, they can be generated. That is called a synthetic data generation. So when we talk about a synthetic data generation, basically it is a process to creating a artificially generated data that mimic the real world data, which is equal to or like look like a real world data in a structure, distribution, and properties, but without exposing actually sensitive or private information. That means they are not exposing the particular specific person or organization sensitive or private information. There may be general data may be possible. So synthetic data is not collected from the real events or people. Instead, it's generated by the algorithms or softwares or programs, often based on the statistical models, simulation or AI, especially generated model like a JN and LLMs. So those are considered basically to use to synthetic data generation. So Gen basically what Gen is responsible to create the images or generate the images, and which type of images? Obviously synthetic images generated. So this is basically considered as synthetic data generation model. Clear? So what happened? We just what is the life cycle or life process of this particular synthetic data generation? We just need to generate the data, control the data, and automate the data. Synthetic data generation. So there are a lot of tools are available nowadays, which will with the help of these tools we can create a synthetic or generate a synthetic data of a particular domain. You can see this one. So the data is mostly AI, synthesized AI, hazy, Socrates, tools for synthetic data generation. So now those are tools basically which we can use for create a different type of data. CVedia, Critel, you can note down this. So those are the basically softwares or tools available which will help to us create a synthetic data which is not actually exist in the real world, or it is basically used to create a fake data. So you can use a Datomize, mostly AI, synthesized, hazy, Socrates, Medoclone, on OneView, rendered.ai, CVDI, and Gritter. So those are the basically considered as a what as a synthetic data software, synthetic data generation software or tools. Now, so this is the practice question, but don't worry. So I think it is all about from my side. So I have tried to cover all the topics here because each and every model require too much time for discussing the in detail. So I just go to I just throw some lights on it, which are the important models of related to the generative AI and LLMs. Now, this is the time for one hands-on. Uh, I have one problem. You need to be implement or you need to be integrate one Python application which is basically which is basically able to answer the of your asked question. So you need to be implement a small type of a chat application using any model. You can use a model of generate Google Plenty 5, or you can use a model of LLM Llama 2 model, or you can use another model if you know, no issue. So please try, everyone try. You have a half an hour, and after the half an hour we schedule a one quiz. So I will share the link on the chatbot for a Google that is a Google quiz link. So just you need to do the one implementation. You need to be implement one kind of a small chat application which is basically able to answer of the given question, and you can integrate any model, LLM model, either as we have discussed the LLM like a Google Plenty 5 or Metalama, or you can also use your own data or LLM model. Okay, no issue. The uh, concern about the model is not there's no any concern. You can use any model. Okay, but we need to be implement this one, and after 30 minutes we will plan the quiz. So I will share the link. So please everyone do this one. Everyone try to implement. You can share, you can access the resources which I have shared on the drive, Google Drive. So you can take a help from the that particular code and try to implement a small application. Okay, so everyone try it, and after 30 minutes we just do the quiz.
So the application will be similar to a chatbot.
Yes sir, yes sir, as we have discussed in our session also, like similar like this.
Okay.
Yes.
Sir, can you repeat the instructions?
You need to be try to implement a small chat application or an application, AI based application which able to answer the asked question by the user. Suppose you give some input prompt, you ask some question to the application, it should be answered. And for this purpose you can integrate or implement any LLM like Google Plenty 5 or Meta Llama model or any other model also. It is your choice. Okay, you can also use any Hugging Face platform models also.
Okay, sir.
Yes.
Sir,
Yes, sir. Yes, sir.
sir, is the repository for MetaLlama gated? Like, do you have to ask for permission?
There is a Hugging Face platform. You need to be take a access token from the Hugging Face platform. You need to be create account and
Yeah.
take login.
Yes, I did that, but after entering the access token and then trying to execute the next code snippet, it's asking to submit the details so that I could be given access to access the repositories.
Yeah, you need to be submit the detail and then you will access the repository. You will get a approval mail, approval confirmation
Okay,
for to access the mail.
sure.
Yes. Sir, Prasiddhanak sir, basically, this time is for implementing one application. I have assigned one short application to you. You need to be implement some chat application, which is basically give the answer of the asked question as a prompt. So you can implement or integrate either any model, either yes. So you need to be integrate either a Google Plenty. Can you show me your screen? Can you show me your screen? Can you show me your implementation, please? Okay, okay.
So is this the same for Google Plant DeFi as well? Do we have to submit our details for access?
Yes, and you will get a mail on, or you will
Okay,
get a access approval mail on your mail ID. Then you can access this one.
okay.
Yes. Sir, you need to do in a Google Colab notebook. You can do in Google Colab notebook. Sir, I have already given this task 15 minutes before, and you have a 15 minutes more. So you can execute only one session at a time. Only one session at a time.
Sir?
Yes, ma'am.
Sir, it's saying that I have a name error and that the word pipeline is not defined, so it's not running my program.
Can you share your code? Can you share code?
Sir,
Your
I just
screen?
sir, I just made a copy of yours and then I used my access token for MetaLlama, which I already got permissions for.
You have given the access key. Can you share your screen? Can you
Yeah,
share
sure.
this? Yes, please. Yes, have you shared?
No, 1 second, sir.
Okay, okay. Yes, have you shared, ma'am?
Sir, just give me 1 second.
Yes, yes, ma'am. Yes. Yes, ma'am. Yes. Can you show your code from the top? Y- Yes. Yes, this system is installed successfully. Have you chosen the T4 GPU? Move on the right hand side where it is a written a RAM disk. Can you move on the right hand side of your screen? Yes. Click on the drop down box. Click on the drop down box. Yes. Click on the change the runtime. Click on this one. Yes. Obviously it is T4 GPU selected. Okay. No issue. Just cancel it. Cancel it. Okay. Move on the top side. Move on the top side. So I think no, scroll up, just scroll up. So I think it is successfully installed. Okay, and next, do the next step. Which is the next step? Yes. Which model are you using? Metalemma. And ma'am, you need to be mention the token. You can see this one token. Oh, just above, just above. Yes. So you go, yes, model name, and you need to be put the token key. So you need to be go to the Hugging Face platform. Go into Hugging Face platform.
Sir, so I have the uh um like access token, so I'll just copy and paste it here and here and then it'll work.
Yes, yes,
Okay, sir. Okay, I'll try that. Thank you.
yes. That then it will work. Don't worry.
Okay, sir.
Okay, okay.
Thank you.
Welcome. Sir, can you share? Can you share your screen so I can see? Please share your screen. If you will share your screen, I will can easily identify what will be problem. Sir, have you shared the screen? In your Zoom window, you need to be click on the share button, which is the basically uh, up button up, or you can also press Alt plus S. When you press Alt plus S, it asks it will display appear a window, shared screen window. You can just click on the entire screen and just share. Sir, press Alt plus S. Alt plus S. To share the screen. Or there's one green arrow button is there at the bottom side of your window. You just click on the share, it return a share. You just click on the share, it windows appear. You just click on the entire screen and click on the share blue button. Then your screen will be shared. Yes. Sir, you need to be defined. Just move, just scroll up. Again, scroll up. Just wait, just wait. Can you scroll up? Again, scroll up. Have you tried all this step? First step, have you tried this step? Executed this step? Have you executed this step? Just click on the run button at this, yes, and see what happens. You need to be, whenever you open the Google Colab notebook, you need to be execute all the steps from the top. Just wait up to finish this step. It will be installed all the libraries, and then click on the second step. After this one, just scroll down. After the execution of successful execution of this step, you just say yes. You just execute the second step, then third step. So step wise, when you try to execute, it will work. Don't worry. After after execution after this statement, you just try to execute another step, second step. So each is basically when you execute a stepwise the entire code, it will work. Don't worry. Now can you stop your screen? Yes. Anybody else facing any difficulty, any issue? How many have tried this one? Please raise the hand. How many tried this one? Any type of model? Yes, please raise the hand. Idrish, very nice. Ayushi Gupta, very nice. Khushi Jain, very nice. Too good. And Sanjanal, very good. Tanmay, very good. Any other? So 1, 2, 3, 4, and 5 and 6. Vasundhara ma'am. Okay, very nice. 6 people have did this one. Anybody else? What about the others? Good. What about the others? Okay, take 5 minutes more and tell me what happened. Very good. Vaibhav also. Yes. Yes, very nice. Raj Nayak sir also tried Lemma model. Very good. Is it successful executed successfully, sir? Raj sir? Too good, too good. Perfect. Very nice. Okay, lower your hand. Just down your hand. Okay. So I'm going to one quiz link with you on chat box. Please, you need to be attempt this quiz. It is a 15-minute quiz. All of you required to attempt this one. So please be ready. All of you, what are you doing? Just pause the things and try to attempt this one. So I'm going to share the Google link, quiz link. Please attempt this one. So I have shared with the chat box. Everyone please open this and try to attempt. It is a 15-minute quiz only. After 15 minutes, I will just close this one to accept to accepting the response. So just need to be closed or submit in 15 minutes. Everyone attempt this one. Have you got a link? Yes, please. Have you got a quiz link?
Yes, sir.
Okay, okay. Those who have completed, just wait. Yes, sir. Akshay, sir, what is your doubt? Akshay, sir, what is your doubt? Can you tell me? I check, okay. Those particular answer I will check, okay. Yes, Mia Bhatia, yes. Please tell.
So quiz is saying in the question which asked for CSV, the answer seems to be wrong.
No,
Yes.
ma'am, it is a comma separated version, not a values. Values basically different. So version of this particular file is appropriate. Basically, sometimes we say it is in general context we say comma separated values, but it is a version.
Okay, thank you.
Yes.
Answer the last question. None of
Which
the
one?
last question.
Last question is what? Can you just read out the question?
Yes. Which one code is correct for the given output? Output is 24, and the print statements were given where none of these match the output.
Yes. So what you have replied?
Uh, may I share the screen to show?
Sorry?
May I share the screen to show?
Yes, yes.
So this one.
How this one?
Like none of the options really match the output.
Because last one is 16x 16, then is a it is a what? It is a XOR operator. Bitwise XOR. So 16
Uh,
XOR 8. So it become 24.
yes, yes,
Clear?
yes.
Okay.
Sir, what next?
All of you have submitted? Yes, please.
Yes, sir.
Yes, it is a comma separated version. Perfect. Perfect full form, it is a comma separated version. In general, in formal language, we basically talk about the comma separated values, but it is a comma separated version. Okay, so anybody any confusion now? Yes, please. Anybody any confusion, any query, any doubt is there? Please ask. It is a open platform. You can explore, no issue. Okay. Some places it written as a yes, at some place it is written a comma separated values, and some platform it is written a comma separated version. So I will show you, just see what is the exact. Okay. I'm suppose I excel one Excel file. I will show you with the example. Just I downloaded, suppose this one. Okay. And see, when suppose I try to this file in a other format, so I choose a format, like I choose a format as different version. So you can see the format basically is a CSV, comma delimited. So when we talk about a comma delimited file, CSV file, so it is not written here in full form, but I will show you when it is written in a comma separated version, not a value. Just wait. I just open the one CSV file and try to show you. Yes, I think JP loan data.csv. Basically, in this particular office, it is not shown, but otherwise, it is basically show comma separated version. I just try to save in other format. See,
But on Wikipedia, it says comma separated values.
what I said, basically, generally, it is a in general informal language, it is referred as a comma separated value, but actual name is a comma separated version. Okay. When you are trying to save some file in CSV format in Excel, so it will get you exact name. Just wait. It is show. Not separated. Okay. So, okay, I will consider it. Don't worry. If you are saying, because sometimes it use no, it is not a we cannot say it is incorrect, but appropriate name is a comma separated version, not a values. So yes, please. Regarding apart from this, there is any doubt, any confusion is there? If you have, please ask. All of you have submitted this one? This quiz? All of you have submitted this quiz?
Yes, sir.
Okay. So if you have any issue, any confusion, any doubt, please ask.
So on Hugging Face, is there any expiry date of the user access token or is it unlimited?
User access token, basically it is not any expiry date. Until you have a access login or login with the particular Hugging Face platform, you can access.
Okay.
Yes. So, okay, thank you so much everyone for hearing me patiently. So, if you have any question, any query, or if you want to say something, please say.
Sir, when will we get the certificate, sir?
It is this information regarding the information about the certificate. You will get the update on WhatsApp group. Okay.
The
So
certificate will have these marks?
no.
No. Okay.
No. It is just an internal evaluation.
Yeah, okay. Thank you.
Yes. Okay. So thank you everyone.
Okay, thank you, sir.
Have a nice day.
Thank you, sir.
Thank you, sir.